I want to look at some more examples of linear inequalities, and these type of linear inequalities are called compound inequalities, as you'll see why here in my example. For part A, for example, I have 3 is less than p plus 3 over 8 less than or equal to 8. So here I have more than one inequality symbol, and that's what we mean by a compound inequality. What we're really saying is two things at the same time. We're saying that p plus 3 over 8 is greater than 3, and at the same time it's less than or equal to 8. Okay, so here this p plus 3 over 8 is sandwiched between the 3 and the 8, and we need to figure out what values of 3 satisfy this. Okay, now the laws of linear inequalities work the same way. If you need help with that, I have a video on linear inequalities, and again the principles follow the same way. Alright, what we need to do here is to get p by itself, and so the way I'm going to do that, first of all, just ignore the less than or equal to 8 for a second. If I just had p plus 3 over 8 is greater than 3, what would you do? You need to multiply both sides by 8. Okay, so now this time I don't only multiply the middle by 8 and one side of here on the left by 8, I multiply everything by 8. So whatever I do in the middle, I have to do to all three parts of this inequality. So I have 8 times 3, which is 24, less than p plus 3, which is less than or equal to 64. From there, I need to get p by itself, so subtract 3 from everything. So I get 21 is less than p, less than or equal to 61. And there it is. Okay, now what we want to do though is put this in interval notation. So if you think on a number line real quick, here's 21, here's 61. 21's not included, 61 is. How do you know that? By the way the symbols are written. Right, strictly less than or strictly greater than gets an open circle. Less than or equal to gets a solid dot. Alright, and then so p is greater than 21, so that's out this way, but at the same time is less than or equal to 61. So here I'm talking about the interval between 21 and 61. So as a solution, I'm going to write 21 to 61. 21 is not included, so I put a soft bracket or a parenthesis. 61 is included, so I put a hard bracket. And there's my answer. Now what this means is that any value of p between 21 and 61 will satisfy the original inequality that we started with up here. Alright, so let's do this again. Let's look at b part. So this time I have negative 1/4 is less than or equal to x over 2 minus 3 is less than 5. Alright, and so I'm going to solve this the same way. And what I want to do is I don't like the fractions. Last time we multiplied everything by 8. This time I'm going to multiply everything by negative 4. So multiplying everything by negative 4, and don't forget, when you multiply into an inequality a negative number, what do you have to do? You have to flip all your signs. So here I have negative 4 times negative 1/4 is positive 1. I have to flip my sign so that becomes greater than or equal to, let's see, negative 4 times x over 2, and then a negative 4 times a negative 3 becomes a positive 12. Flip my sign again, and then 5 times negative 4 is a negative 20. Alright, so here I have 1 is greater than or equal to, what does this become? Negative 2x plus 12 greater than negative 20. Now I need to get the 12 out of there, so subtract everything by 12. So negative 11 greater than or equal to negative 2x greater than or equal to negative 32. And now I'm going to divide everything by negative 2. So when I divide by a negative, so I have 11 halves, I have to flip my signs back, right? So flip my sign again, and negative 32 divided by negative 2 becomes 16. Okay, so there's my solution. I have 11 halves less than or equal to x, less than 16. Alright, so on the number line, you think here's 11 halves, here's 16. 16 is not included, but 11 halves is. I'm greater than 11 halves, but at the same time less than 16. I'm in between there and there. Okay, so that means as a solution in interval notation, I have 11 halves with a hard bracket, right? The 11 halves is included. Up to 16, 16 is not included. And if you're a little confused by what we mean by included and not included, that means 11 halves plugged in for the value of x will give me a correct solution to this inequality. However, 16 will not, but 15.9999 will give me a correct solution in this inequality. Okay, compound inequalities, once you understand linear inequalities, is not really that difficult. We're just adding one extra side to my inequality, and so you have to keep up with balancing two sides of an inequality instead of just one. But if you have any questions on it, I'd be glad to help. Please let me know, and thanks for watching.